In our second example, we're again asked to find the sine, cosine, and tangent of the double angles. This time we're given information about our original angle x, that the cosine of x is negative 1/3, and that the angle is between pi and 3 pi over 2, which puts it in the third quadrant. So we're going to have to draw that angle in the third quadrant, create a triangle, so we can figure out what the sine of x and what the tangent of x are, so that we can use those in the double angle formulas. So if we draw our triangle, we're going to wrap around to here. So if we extend, create our right triangle here in the third quadrant. So if the cosine is negative 1/3, that means the adjacent side is going to be negative 1. The hypotenuse is going to be 3, and then using a little Pythagorean theorem, we can figure out that that third side is going to end up being root 8 or negative 2 root 2. Negative because we're in that third quadrant, we're going down, and then 9 minus 1 in our Pythagorean theorem is 8, square root of which simplifies into negative 2 root 2. So that means the sine of x, which we will need for our double angle formulas, the sine of x is going to be opposite over hypotenuse, so negative 2 root 2 over 3. And then the tangent of x is going to be opposite over adjacent, which is going to be negative 2 root 2 over negative 1, or just 2 root 2. So we can start with the sine of the double angle. So sine of 2x, we just have the one formula for that, which is 2 times the sine of x times the cosine of x. So if we work on that, we've got 2 times, we just established that the sine of x is negative 2 root 2 over 3 times the cosine of x, which was given to us as negative 1/3. So if we put the 2 there out front over 1, we can see again there's no cross-canceling or reducing that we can do. So we just got to multiply all the tops. 2 times 2 root 2 is 4 root 2 over, on the bottom, 1 times 3 is 9. And we've got 2 negatives that we're multiplying, so our answer turns out to be positive. So our sine of 2x is exactly what we see there. Again, for the cosine of 2x, we've got multiple options as to what we can use. Now, I like to choose one of the identities that will result in the least amount of kind of hard arithmetic that we have to work through. So out of those choices, I think the best option is cosine of 2x equals 2 times cosine squared x minus 1. And the reason is that this one just deals with cosine of x, which is going to be a little bit easier for us to plug into a formula and multiply out than if I have to use the sine of x. So I'm going to use this one this time. So 2 times negative 1/3 squared, so cosine of x is negative 1/3, so negative 1/3 squared minus 1. So we've got 2 times 1/9 minus 1, or we'll kind of keep on going sideways here. So 2 times 1/9 is 2/9 minus 1. So 2/9 minus 1, so 2/9 minus 9/9 means we're going to get eventually an answer of negative 7/9 as our cosine of 2x. And then once again, we could use the identity that we have for the tangent of 2x, or since we've got the sine of 2x and the cosine of 2x, we can go ahead and just use the quotient identity, which says that the tangent of 2x is going to be equal to the sine of 2x over the cosine of 2x. I can just divide my two answers that we got. And so if we do that here, we've got 4 root 2 over 9 divided by negative 7/9, or we can rewrite that as 4 root 2 over 9 times the reciprocal of that bottom fraction, so times negative 9/7. And so then we can see we've got some pretty simple reducing here. The 9's go, and so then we're left with negative 4 root 2 over 7 as our tangent. of 2x. So again, we could have arrived at that answer by using the actual tangent double angle identity, but if we've already got those other two, I just think the easiest approach to take is to just divide those two answers, since we're oftentimes going to end up with some pretty simple cross-canceling reducing, and we don't end up having to rationalize denominators or anything like that.